In this video we are going to look at factorising non-unitary trinomials. So we've seen this before and some of you will have attempted it. This is when we're factorising ones where we don't have a single square term. So here we've got 4n squared, 5n squared, 6n squared and 2n squared. We've dealt with all of these situations where we've got positives or a mix of positives and negatives. So really all we're doing is we're adding an extra wrinkle to the problem with this non-unitary bit at the front here. We know from previous work how to set these up. We know the 4n squared would appear here in our grid if we were multiplying out two brackets. We know down the bottom right there we'd have a 3. And we know these two boxes here are going to have some n's in them, and they're going to have 13 n's altogether. We also know these two boxes will multiply together to give the same product as these two boxes. So multiplying these two boxes together will give me 12n squared. So I need to find two numbers here, two amounts of n here that will add up to give me 13 and multiply together to give me this 12n squared. So if we think about the coefficients, I'm dealing with one of these combos here. 1n plus 12n gives me 13n. So that is my first pair right there. That's my correct pair right there. Everything's positive in this grid, so I can start pulling out factors without worrying too much. I'm going to work along the way here. 4 and 12. Both of those have got a common factor of 4. N squared and n, they've got an n in common. I know 4n here, so I can fill in the top of my grid. 4n times a single n will give me 4n squared. 4n, to get 12n, we need 3 lots of 4n there. Now I've got this, I can figure out what goes down here. N times 1 will give me 1n. Quick check, 1 times 3 does indeed give me the 3. So this will factorise to n plus 3 and 4n plus 1. So what we've done is we have taken the process of multiplying out brackets and we've reversed it. So we have factorised this trinomial. Right, second one, we've introduced a negative, but our process is still the same. I'd have a 2 by 2 grid. I know here I'll have 5n squared. Down here I'll have an 8. And in these two boxes I'll have some n's, which will total up to negative 22. So I'm going to have some n's in there. I know these two boxes will multiply together to give the same product as these two. So 5n times 8, that'll give me that 40n squared. Now, I see here these yellow boxes are going to have to add up to give me some negatives. So it means there's going to be negatives in here. However, these two terms have multiplied to give me a positive. So this means both of these are going to be negative, because I need negative something times negative something to give me positive something here. I'm going to start listing all my factors of 40. So I could have 1 and 40, 2 and 20, 4 and 10, 5 and 8, and that's my lot. Going down my list, 1 and 40. Well, if these both are negative, I'm going to have negative 1 and negative 40, which will give me negative 41. So they don't work. Negative 2, negative 20, they will combine to give me that negative 22. So negative 2, negative 20, using that factor pair there. So these two terms will add together to give me this. My two diagonals in my grids multiply to give me that. So working with this top line, they don't have a number in common, but they've got an n. N times 5n will give me 5n squared. N times negative 2 will give me that negative 2n. Down here, 5n times negative 4 will give me that negative 20n. So let's just quickly check this. A negative times a positive will give me a negative. 4 5s are 20, and I've just got that single n. I can use the last box as a check. A negative times a negative is a positive. 4 times 2 gives me the 8. So this will factorise to 5n minus 2, n minus 4. Next one, a couple of negatives in here, but we still go about it the same way. I know 6n squared would be the top right, negative 6 would be the bottom left. In this box, I'm going to have some n's, which will combine to give me negative 5. So an n and an n. Now, these two boxes multiply together to give me negative 36n squared. So my two yellow boxes need to multiply together to give me negative 36n squared. This means one of the boxes will need to be negative and the other will be positive. Because the yellows combine, add together to give me negative 5, it means this negative is going to be greater in size than this positive. So I'm going to list all my factors of 36 here. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and itself, and just sort of consider these. So negative 36, positive 1 would give me negative 35. Positive 2, negative 18, that will give me negative 16. Negative 12, positive 3, that won't work, that would be negative 9. Positive 4, negative 9. Positive 4, negative 9. My zero pairs will eliminate there and leave me with 1, 2, 3, 4, 5 negatives. So positive 4, negative 9 is what I'm after there. I've got my grid filled in. I can start pulling out common factors. I'm going to go up and down the way here, just because this is all positive. 6 and 4. There is a common factor of 2 when I consider the numbers, and n when I consider the letters. 2 times 3 will give me that 6. N times n gives me the n squared. I need 2 lots of 2n to give me that 4n. Now, both of these are negative, so it's looking likely I'll be pulling a negative common factor out there. 3n times negative 3 will give me the required negative 9 there. Check with the last box, a negative times a positive gives us a negative. 2 3s are 6, so that's correct. This means it factorises to, pair of brackets, 2n minus 3, 3n plus 2. Last but not least, got this one here, 2n plus 2n squared plus 3n minus 9. I set up a grid. I know 2n squared will go up there, minus 9 will go in there, and in these two boxes I'm going to have some n's. The 2n squared times minus 9 gives me minus 18n squared. My two yellow boxes here will also need to multiply together to give me that minus 18n squared. So this means one of them needs to be negative and one of them needs to be positive, because a negative times a positive gives me a negative. So I need to list my factors of 18. 1 and 18, 2 and 9, 3 and 6, and that is it. These two boxes need to combine to give me this positive 3n. So it means if I consider the size of the positive and negative, the positive one is going to have a larger size. So one of these numbers is going to be my positive, and one of these is going to be my negative. So positive 18, negative 1 would give me positive 17, no good. Positive 9, negative 2, give me positive 7. Positive 6, negative 3, cancelling out those 0 pairs, leaves me with 3 positives, positive 3. So I know I am dealing with positive 6 and negative 3. I could have put positive 6 up here and negative 3 down here. It would have had no impact on the final answer. It would just mean the two solutions, the two brackets, the two factors are in different places. I'm going to start up and down the way just because that's all positive. So a common factor of 2n. 2n times a single n will give me 2n squared, and 2n times 3 will give me that 6n. Both of these are negative, so there's probably going to be a negative common factor out here. N times negative 3 will give me negative 3n. Let's check with the last box. A negative times a positive is a negative. 3 3s are 9. So I have got 2n minus 3, taking it from the top there. My second factor will be n plus 3. n plus 3. So very, very, very similar to what we've done before, but we just need to remember that we're not looking for factors of this last digit, this last term. We're using the fact that the two diagonals always have the same product. So you've got to multiply these two together and list the factors. On your worksheet you've got exercise 4, plenty here to keep you busy, 18 in total. They start with fairly small numbers, and as we go on we can see the numbers you'll be working with get larger and larger. But as long as you are organised and list your factors, starting with 1 in the number you're working with and working up from there, you should be able to find the numbers that work for each of